Hello, people. So, guys, I've been waiting for so long for this event. So, we'll be discussing about the different basics of MATLAB with a problem, which is a very interesting problem called the pendulum problem, together. So, let's get started. So, yeah. So, what's actually MATLAB? I guess hope you guys are all ready for the event. Let's just start with it. So, it'll be me, Annapurna, and Ritiman who will be doing the event together. So first math lab, math and lab. Math is matrix and lab is laboratory. So it's actually a high level programming language. This is mainly the parent company's math works. Okay. So you guys, why should you guys been asking the WhatsApp group, why should I learn math lab? Why is it even important? So you guys know that doing code in C++ and C is very tedious, and in Python everything is a very long code. MATLAB, it makes it very simpler, and showing some mathematical tool in your programs will make it more impressive. Cool. So that's why we will be doing MATLAB. So this also gets you a lot of job opportunities too. So setting up the environment, you guys have the link, right? We'll be sharing the PPT, so you can look at the link, log in. It is free for VIT students. You just have to sign in your account, create an account. So basic commands are clear, CLC, who and date. So what is actually clear? So you have something called workspace in MATLAB. It clears every single thing in workspace. Then inside of your MATLAB window, you have the command window. In the CLC will clear every single thing in command window. That's why you will notice in every MATLAB function you will have for CLC and clear. So that you clear every single thing, so you won't have problem in the future. So who will shows all this different variable in that particular scope of your program, and date will call the date. So the different basic mathematical functions will be all your trigonometric functions like sine, cos, tan, secant, cosecant. So let's start with matrices. If matrices is a simple thing in MATLAB. So how do I create a matrix? There are different types of matrix. One is 1D, 2D, 3D, every single type. So 1D. So you create a variable x and assign, you have two rectangular brackets. Cool. So x is equal to for left rectangular bracket 1 space 2 space 3 and right rectangular bracket. What does this signify? So by giving space, you're saying that this is a different element from the other elements. So this is how we create a 1D matrix. How do we create a 2D matrix? As we had spaces to differentiate different elements in a particular row, now we have semicolon to differentiate the columns. Cool. So 1, 2, 3, semicolon 4, 5, 6, semicolon 7, 8, 9. So operations of matrix, there are different operations. Arithmetic operation. If you see an arithmetic operation, so it's like a plus 10. You have a matrix A and you do a plus 10. Cool. So you actually add 10 to every single element in that matrix. For example, you have a 4 and you have added 10. So what does that mean? So you add 10 to the first element 4, then 10 to 7 and 10 to 3. You are adding it to a respective element. So same goes with your minus 2 too. Then you have a b and you do a minus b, you get the answer 1 minus 4, 2 minus 5 and 3 minus 6, similar with a plus b. And you have different trigonometric application, as I said before. So in trigonometrical applications, you just say sine of b, it finds sine of single element, every single element in the matrix. And transpose of a matrix. Transpose is just reversing the whole matrix, which we study in 11th and 12th too. It's just rows becomes columns and columns becomes rows. So matrix multiplication, which is x into whatever it is. So we have learned this matrix multiplication 11th and 12th. It does the same thing. So power. Power is A. A is my variable over here. A dot the power symbol and 2, which finds square. So A is 1, 2, and 3, and A square will be respective element square 1 square, 2 square, 3 square. And concatenation. Concatenation is nothing but joining different things. So I have a matrix A, which is 1, 2, 3. So I want a matrix, a new matrix, which is like A and again A, same row. So what do? So you write B is equal to left rectangular bracket A comma A. So um, it's basically like having 1 2 3 1 2 3. Now what if I want to have it in different rows, like 1 2 3, and the next row I want 1 2 3 instead of the same row, right? So what I do is b is equal to a semicolon a. Cool. So this will make a perfect matrix of 2 into 1 dimension. Then about complex number. Complex number is nothing but a plus b iota. So square root of minus 1 gives you 0 plus 1 iota. Similar with the other equations over here. And size is nothing but finding the dimension of the given matrix. So it's like 5, 6, 8, 2. You have a matrix like this. Size of A says 3 rows, 3 into 4. So different ways of matrix multiplication. Before we studied a different matrix multiplication way, which is A into B, which is what we have been doing every respective row to other column and doing it 3 times and adding it, which we study in 11th and 12th. So this type of matrix multiplication will do respective element. Basically, like it's like addition, subtraction, which we studied before. A dot into B will do respective row or the column multiplication of a matrix. And what's an identity matrix? We know what's an identity matrix, right? So what's the function of format in MATLAB? So it's like u is equal to I. I means finding the identity. U is equal to I of 3 will make an identity matrix of 3 into 3 square. But in MATLAB, you can make of like identity matrix of different ways, like 4 into 1 size also we can make. I'll just have a size is equal to 4 into 1 and u is equal to I of size. It'll make a something like 1000. Cool. um you have different matrix operations and easy way to create a polynomial. Okay, so you just say poly to sim, then in round type and writes it similarly. Like you have given polynomial 3 to 1 and 0.5. It writes it like 3x square, 2x square, sorry, 3x cube, 2x square plus x plus half, which is zero point 0.5. Now I have this x, but I don't want x. I want some other variable in place of x. So I'll take a variable z. So instead of x, I have here, according to the equation, I'll have 5z square, z power 5, 0, z power 4, 0, z power 3, 0, z power square, and 3z plus 9. And I don't want just z, I want something like pu. Not just pu, you can have any different word. You will just have fun too. So similarly, you can just do it that way. And MATLAB as symbols, okay? So like in your C++ and C, you declare a variable saying like char abc, int abc, something like that. Similarly over here in MATLAB you have something called syms. What does this do? Syms A, B and C. This is three different symbols you are creating in MATLAB. So what's the difference between symbols and variables? Variables exactly need to be used and assigned, and symbols can just be remaining like that. Cool. So you guys are getting this PPT. So I have attached few fun questions. You guys can go and do it later. It'll be a practice. You have answers too in that. So yeah, in a function mainly, you guys know, right? Like for example, like we have C in, C out, and things like that. So we have similar way prompt and input. Prompt is something very similar to C out, and input is something very similar to C in. Prompt shows something to the user, like what is the original value, and x is equal to prompt. So you're after you say what's the original value, and you get an input from the user, which is x, and you show the output. So control statement is your if else. It's basically this MATLAB. You can see MATLAB turning out to be very similar to your normal programming languages like C, C++, and Python. So you can just give if and then you're ending that statement. And you can also give it similar to if else. You can have if, else if, and else and end. So end is saying that you're ending this whole loop. Cool. So you can also have a while statement, you can have a switch statement. It's very similar to your normal coding languages. You just have a look over here. So you have switch, you have case statements, and you have an otherwise instead of default. So otherwise and end. So we will see what's indexing in matrix. So I have in matrix V 16, 5, 9, 4, 2, 11, 7, and 14. So what's an indexing of a matrix is just pointing out a matrix. I would like you guys to know at one point in normal arrays or whatever in your normal programming languages we learn, it starts from zero, the indexing 0, 1, 2, and 3. But here it won't start with zero, it starts with 1, 1, 2, 3, 4. So basically here the 16 will be v of 1 is 16, this 16. Cool. So when I call v of 3, it goes and points to the third element. So it says 9. When I say v 1, 5, and 6 in square brackets, I mean I want all these three values, which is 16, 2, 1, 11. When I say v 3 colon 7, it says every single value between 3 and 7 I want it, which is 9, 4, 2, 11, and 7. And if I say 5 to 8 and 1 to 4, is it gets it in the same order, and we end is pointing at the last element. And 5 to n takes every single element between 5 and end of the matrix. And v2 n minus 1, which will be second element till the second last element, which is 5, 9, 4, 2, 11, and 7. So yeah, you guys can replace different elements after making the element. Suppose you have a matrix and you realize that you have made an error and you want to replace that element, right? So it'll be like v2, 3, 4, and you point out that elements 10, 15, and 20 means v of second, the second element of the matrix, I want to replace it with 10. And third element of the matrix gets replaced by 15. Fourth element of the matrix gets replaced by 20. You can note, you can just look over here in this matrix, you will have an idea what it is, right? The second element has been replaced by 10, third has been replaced by 20, and fourth has been replaced by 20. So similarly, v2, 3, if I just give a number 30, that means every single element I am specifying to replace will be replaced by 30. So the second and third element will be replaced by 30. Cool. So guys know what is magic matrix, right? Magic matrix is same something which was found by Ramanujan sir, which is like every single, if you count all the elements in rows or count all the elements in columns or count all the diagonals, any way you count it, you get the same element, same answer. So it's like you just have to call magic and give the dimension, it makes a magic square on its own. And plotting is very important in today's session. Okay, so you have something called left plot. So, instead of calling f of x, we write at the rate of x, f plot at the rate of x, x square, which means I'm calling x square function. Cool. So you can see it has just taken its default values, and we gave the default interval as -5 to 5. And you're giving a specific integral. Before it was like -5 to 5. I'm giving an interval 0 to 3. I want my x square plot from exactly from 0 to 3. It will be f plot at the rate of x, x square, 0 to 3. Now I'll say, Arey, I don't like this blue color which is MATLAB is giving. I want a different color. So I'll say, I'll give an element extra at the end saying R. This way, I'm giving a specification of the graph which I'm drawing. So the take a screenshot. I'll get the PPT at the end. So here you can see that the different colors, B means blue, G means green, R is red, and symbols, line types, everything you have, and you can modify graph however you want. So you have f plot. So what does f plot do? F plot is basically modifying the properties of the existing graph you have made. Okay. So 2D, we have seen 1D plot, right? Now we'll just see 2D plot. So in 2D plots, for example, like you have an x function, x is equal to 0, and y function, y is equal to sine x. Plot x comma y. It is very simple. Have a variable x, have a variable y, given function for x, given function for y, and plot x comma y. That is your 2D. So attributes in 2D plot, you guys know this. I have I just don't want to have single plot in my graph. I want 2 3 plots. Okay, very simple. What I do, I have one common variable x, I have y1 and 2, y2. Okay, y1 is sin x, which is my first function, y2 is cos x, which is my second function. So we plot the variable x comma y1, which is sin x, x comma sin x, and x comma my second function, which is cos x. And I have been giving just this sign over there to show the change. And my legend is sin x and cos x. Cool. Legend is what you have written in the top right corner. So you have different types of 2D graphs and 3D graphs. You guys will know 3D graphs later. So different functions, like you have seen in your computer science, you have two different kinds of function. Inbuilt function use a different function. What is inbuilt function? Inbuilt function is a function which has already been made by MATLAB for you to make your life easy. Why do we need a user defined function? There have been situations where you have to write the same function again and again and again, or same set of commands again and again. You use a user defined function. So basically, sine, cos, square root, I, every single thing which we discussed before were inbuilt functions. What's a user defined function? The function is like fun is equal to inline, and you create a function x square minus x and x, and fun is your the function you have created. So how do I find a mean? Well, you guys know what mean is, right? So how do I find a mean? I have x is equal to, I have created a 4 into 3 matrix, and I'll say m is equal to mean of x. What does it do? It every single column it takes and finds its mean and gives your value. Hope you got this answer. Got it. Um, the find function, yeah, piecewise function. Piecewise, you guys know, right? The same value, the upper part has plus x and same value of plus x, and down it has same value of negative x. So it basically you have different ways to plot it. So if you say fx is minus 2 and fx is 2 and plot it x comma fx, you are writing an if else condition over here. You guys notice it, right? If my x is lesser than 0, plot minus 2. If my x is greater than 0, plot 2. So you can use a switch function. You can make a function on its own too. Function is called piecewise x, and you write the function. You are building a function as we discussed before, like user defined function. So inverse function. Inverse is nothing but I n v. You have a matrix U, and you say v is equal to inverse of U. It finds inverse of your matrix. We knows what derivative is actually, okay.
Um, just to go a
Uh,
little tad slower, the
yeah, sure.
guys in the chat is okay.
Guys, so we know what actually a derivative function is. This is nothing but differentiation of your function. Cool. So you just have to say f of x is equal to x power 4, 3x cube, 4x square, 5x plus 1. And you say df is equal to differentiation f comma x, which is nothing but you're differentiating into a whole function. Cool. You guys know this, right? It's very simple. It's just differentiating the function, saying diff of f comma the variable. And if I say f comma 2 in place of the variable, that means I'm substituting 2 in that variable. Fine. So what it does, it differentiates and then substitutes 2. Then what is x label, y label? Okay, you have a graph. Okay, see, let's just compare this part. A is equal to, you have given a different thing, then you have given a different category, and B, and again a different category, and you are making a bar graph, which is bar the different variables. And x label employee salary, color, and G. See, employee salary, you are specifying the color and you say it is green. I want my employee salary to be x label is nothing but labeling your x axis. Employee salary in green color. Hope you understand this point. So here you have different examples. Okay, population in thousands. So by giving comma, you are writing it in the next line. And you have different things. I'll share you the PPT later then, so you guys know. So you just don't need to have just one single specification for the graph. You can have n number of specifications. Here you can see you have deciding a font size as 12. You are deciding your font weight as bold and color as red. And these are different things. Again, a tableau column you need to know. and creating your function. This is what we said, right? User defined functions. So in user defined functions, you just get the input and input one, input two, function name. You guys would have understood by just seeing this. So function, mean, median, function array. Mean, median is the different variables we are using, and this is how we call function one of array is how we call later. So mean, array length, and you have a if else end. This is just pretty much similar to your normal coding language you have been doing right now, like C, C++, Python. So recursive function, you guys won't need it right now. And we have various funny plots. As I said in the beginning, we have so many funny plots. Okay. So see over here. This is a flower shaped plot. MATLAB is not this very serious thing. Okay. You guys can do very funny things over here. And you can generate heart shapes like this, a heart like this, a heart like this. You can have an earth map. You guys would have never thought you can plot an earth map in MATLAB, right? So world TRV trans demo, it shows every single hemisphere and everything. Okay. You have you can create crazy animated shapes like this. There are different things you can explore in MATLAB. So you have few additional resources over here. So you guys can go through it. Okay. So I'll be sharing this at the end of the session. Now I'll request my co-host, Dhritiman Nandi, who will take you to a very interesting plot, which is pendulum plot, which is the main agenda of this session. Fine, Dhritiman, you continue.
I'm from mechanical engineering. So today our main agenda is to like okay. Yeah, sure, sure. One second, yes. So okay guys. Moving on. Simple pendulum. The our main agenda is to make a simple pendulum simulation in MATLAB. So like before even going to the simple pendulum problem, let's discuss about how to solve a general problem statement. Okay. Uh, so before even going to the applied mathematics, like as Annapurna mentioned, MATLAB is more about applied mathematics. We don't care about much about those proofs like Pythagoras theorem ka proof and all those stuffs because it's not as important for us engineers. We tend to focus more on the applied mathematics ka side. Okay. So approaching a general problem statement. Now, this is like the main part of before a problem solving statement is to ask questions. Like I'm sure you have had many times a doubt like where should we even start solving the questions, right? So first we need to ask the question, okay, what is the question? It's pretty simple if we ask the right questions for our problem statement. So I would say to start clean. Don't look up any materials for now. First, write down all the things that we have to do for problem solving. Right? Like let's say if even if we say simple task like let's say driving a car, what will we do? We will first start the car. We will first start the car. We will then engage our BS and all those stuff. Right? So asking the correct questions is very important. So I would advise to take up a notepad or something and note down any question, all the questions and all the ideas that you have, because pen and paper is the best thing you can do. It will help us in solving the problems and all. Okay. Uh, Moving on. So MATLAB. For MATLAB, our project, let's say Simple Pendulum, we have basically three processes, like the pre-coding part, like understanding what we have to do, the theoretical aspect, the main coding part, and finally presentation. Uh, I would advise everyone to like don't bother too much about the presentation and all at first, because we can do it later on. First, our main goal is to solve the problem and make sure it is consistent with our ideas and theory. Okay, moving on. So let's start with our problem solving. Simple pendulum conundrum. Guys, in the chat, I'm sure you can answer in the chat several questions that I asked. Okay, cool. So what is a simple pendulum? Right, write in the chat if you want. Hello. Can I give you this? Okay. So moving on. Uh, so this is my diagram. As you can see, I have drawn a very beautiful diagram. So for pendulum, it's basically a point mass suspended from a pivot, which and we usually we take a massless thread. Okay, and the effect of gravity is considered. Cool. But one small problem that we face is like if we take a thread, the main issue is that let's say if you look in this diagram, take the pointer. If you look here, you see if I drop the pendulum from here, it will go in a circular path. That's good. But after some time, after when it reaches in this portion, it will start become parabolic path, right? So it is like complicated, and we don't want that in our path problem. So for that, we will assume ki like we have a massless rod, massless rigid rod for our problem. Okay. Now, of course, we need to make assumptions like we don't consider drag of air, buoyant effects of air. We don't consider the friction between the bearings and all. Okay. Next. Now, before any coding, we usually list variables, right? So I want you guys to like tell me what are the variables that we need for our problem. Like we need to store something like length, mass, and time, etc. I just think about what are the things that we need for our problem.
Dhritiman, could you please stop because your voice is not so clear?
I'm sorry. This is not
Dhritiman, could you please check your mic and read? Could you please check your mic?
Is it clear? Is it clear now, guys?
I'm sorry.
Is it clear?
Your voice is not clear, Dhritiman.
Hello, hello, hello,
Your
Yeah.
voice is
hello.
actually breaking a bit.
Let me change it. Now is my voice clear?
Yeah, I think you can go ahead.
Yeah, okay, okay. So sorry for the inconvenience, everyone. Headphone Kaishita. Okay. Uh, so where were we? Okay, continue. So listing all the parameters. So guys, what are the parameters that we need for our problem? Like I told, length and mass. Do we need any more parameters? Can you write it in the chat? So okay, okay. So I guess not many responses. Okay. So for a simple pendulum, we need first a length L full. So we need a length A, we need a mass A, and also we need like we are using MATLAB, so we will store time as a matrix. Okay. So like 0, then 0.01, 0.02, and so on. Okay. We will define gravitational constant G as a constant 9.81, as we all know. Now, since we are doing simulation, we need to measure the velocity and acceleration, right? And also the position. So before enlisting that parameter, you need to understand how to define a state of a simple pendulum. Cool. So let's say we have a simple pendulum here, and we draw the vertical, and we measure this angle as theta. So by using our 11th derivation, we know that this position, we can give it as, let's say, position is equal to this much in x coordinate, which will be, by simple trigonometry, it will be L sine theta, and this much we are going down. Since let's say we are assuming this as the origin, we are going down by this much distance, which will be L minus L cos theta. Cool. Our pendulum is defined mainly using this angle, right? So this is called as the main variable of our system. So this everything we will do will be based on this angle theta only. So uh, for theta, its time derivative will be its angular speed, which will be omega, and its acceleration will be alpha, right? Simple physics that we learned. Okay. So, some mechanics, let's continue with the mechanics of our equation. So, for if we consider the free body diagram, like we learned, we have a force mg, right? And usually we resolve it perpendicular to the rod that we have and normal to the rod that we have, right? So, this would be mgl cos theta, because this angle is also theta, and this will be minus, this will be plus mgl sine theta, right? Now, so not L, sorry, I rushed a little bit. This will be mg cos theta and this will be mg sine theta, right? So now what we will do, which I wrote it here accidentally, is that we will measure the torque of the system, torque or moment of the system about the point O, right? So for that we will write the sigma m is equal to I alpha about O and alpha about O, which is we know. Now this is the force mgl and this is the length L. So the moment will be mgl plus here mgl sine theta is equal to I, and since this is a point mass and that's the main point of assuming ki, like why are we taking a Okay. Why am I having audio issues again? Kind of. Sorry guys for the audio issue again. Let me check. Hmm. Okay, so check. My audio issues are causing me problems. Okay, and now let's see if it's clear. If it's not clear, okay. Continuing. So the torque is mgl sine theta, and the whole moment of inertia is ml square times alpha, right? Cool. So what we get when we simplify is alpha is equal to g by L sine theta, right? So we will also we have minus mgl sine theta because like I mentioned this will be minus and this will be minus because we are taking clockwise torque here. So that's the correction that you need. Okay. So this is minus g by L sine theta. So right. So now this is a differential equation, right? So d square theta by dt square is equal to minus g by L sine theta, right? Now coming back, so this is the differential equation that we have, and solving the differential equation will give us three things. First we will get theta of t. We will then get theta dot, which is equal to omega of t, and also angular acceleration alpha of t, which is already known from this equation, right? The main challenge is how do we solve this equation, right? So for that we can do it by making that simple assumption is sine theta is equal to theta. But the main issue with that is it is only valid for small angles, right?
Dritiman, you're not audible.
Hello, 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 hello,
Huh,
hello.
yeah, yeah.
Uh, I don't know why the audio is breaking. Sorry. Let me now it's clear. Like, is it
It's
breaking
not,
in between?
I'm sorry.
Is it breaking in between?
Yeah,
Okay, okay. Let me. Oh, what is happening? Should I continue now?
yeah,
Uh,
continue. Please go ahead.
okay, okay. Yeah, yeah. Sorry for the inconvenience again. I don't know what is happening with my internet. Uh, so numeric analysis. I don't want to, so continuing on numerical analysis, I don't want you to be too much bothered about the numerical analysis and all those things, because our main focus is on doing MATLAB code, right? We don't want to waste time understanding what is numerical analysis. So to review, what all we have. So we have our length, our mass, our gravitational constant, our time. Now we have theta, omega, alpha. So 7 variables in total, of which mass is not that important. Now we need to understand what are the data types of each of our variables. Okay. So length is a single primitive data type, so double or integer, whatever it can be. G is 9.81, and time is a matrix. So we will start from time t is equal to 0, and we will take small increments, like small step at a time. So that small step we can define it as 0.01 seconds. So it will be 0.01, 0.02, so on till time range, like the final time up to which we want our simulation to run. Okay. Now likewise, we will store this. This will have its own length, right? So this array will have a length of, let's say, uh, n. Shall we say n? So same way we have to define a theta as an n by 1 matrix, like uh, n n columns, 1 by n, one row and n columns, right? So it will store the value for theta of 0, theta of 0.1, so on. Likewise, omega will also have theta for w for 0, w for 0.1, and so on. And alpha will have 0, alpha of 0.01, n. All these things, okay. So enough of this theoretical aspect, this kind of boring aspect. So note this down, note the 7 variables down. Now we will start with the coding aspect. One minute. So let me save this. Okay. So let's go to the MATLAB environment. Okay, so as we know, in MATLAB we have an editor, right? So normally we have this editor right here above the command window, but if we just drag it, then it can be made into a separate window. I will just show you how. Like let's say, okay, now it's not happening. Anyways, you can do it. Okay. Uh, so like I mentioned, first we will define the variables. Okay. And like Annapurna had already taught, we will first type CLC clear all. This will be like clearing all the data types and variables that we have. We will also add close all. This will delete the whole every figures and all. Okay. Okay. Continuing. So for this is like the first part. Now we will select our small interval time dt equal to 0.01 seconds. And I am commenting everything down so that it helps understanding later on if I in case I forget my stuff. So now we need to start with our t range. let's say we want to analyze only for the first 5 seconds, shall we? Now we want to we can also define the only constant that we have, which is g is equal to 9.81. Our length is equal to, let's say, 1 meter. Okay, now we need to find the length of our time matrix, right? Like I showed here. Our time will be from 0.0 to 0.01, 0.02 and so on, right? So we can define that now. So time interval is equal to, we start from 0, we increment by small step dt, and we go till t range. So what this does is basically it will be like time interval is equal to 0 comma dt comma 2 dt comma 3 dt dot 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 till we reach time range. So now we need to proceed to the next step, which is like first declaring the our angle values, our angular speed values, and our angular acceleration values. Okay, so theta, let's say one minute. I want to just verify if I am writing the right code or not. I don't want to make mistakes. So let's say angle A is equal to zeros. This is basically declaring all the elements of the array as of the matrix as 0, and our array size is n comma 1. N is basic n comma 1. Now you may ask, what is n? So basically n is the total number of steps. So let me just write it properly. N is equal to t range divided by dt. So for now it will be 5 by 0.01, which is equal to, simple maths, 5 there. Okay, 500. So our time at our angle matrix will be like 500 zeros in a single row. So now next is W of A, which is the reason why I'm naming it is A, because it's easier if you just give it names and all, and this will help on lettering adding more stuff, like let's say a double pendulum. So I'm just referencing it with the name A as well as a subscript. Let's say zeros 1, zeros n comma 1, then angular acceleration as ACC, and I just made a short form for angular acceleration as zeros from n comma 1. Now since if you look at the pendulum, we have our position as x and y, right? So x is equal to L sin theta and minus L sin theta. So we shall even declare for those as well as zeros. X of A is equal to 0 of n comma 1, y of A as 0 of n comma 1, right? So this is like defining the parameters, and now we need to start by having an initial input, because we are dropping the pendulum from some angle, right? So for that we will have an initial input as well. initial angle. And also, if we want, we can also add the initial speed, angular speed. Like let's say if we want to give it some initial energy, or like we basically having a throw, we can also add an initial angular velocity. So that will be simple as uh, angle A of 1, which is the first element of the array, as input from like Annapurna mentioned, we will using a prompt for our inputs, right? So enter initial angular angle W of A of 1 as input angular speed. So we have defined the initial conditions. Now, since we are not discussing too much about the theory, I don't want to bother you too much about the whole for loop thing. All you have to think, like, since our pendulum is starting from an initial state, right? So what will happen in the next state is defined by the previous state itself, right? So that's how we will do the for loop. So and since we have n steps, so we will have a for loop for n steps. So for I is equal to 1 to n. So like basically this for loop will run n times, because we have n elements in our array to fill, and n elements in our matrix to fill, and keep from your array. It should be matrix. Uh, the angle of A of I is equal to minus G by L A times minus G A of sine angle, right? So angle of I, because we want, so the first equation is basically this equation only, the equation that we have here. One minute, what I'm showing. Okay, this equation. So d square theta by dt square is equal to minus G by L sine theta, right? So basically we are storing, okay, restoring angular acceleration for time I, right? So going back to the code. So this will be just the differential equation in MATLAB. Okay. Now next one. W of A of I plus 1 is equal to current angular velocity, which is equal to W of I plus dt, which is the small time interval that we chose, times acceleration of the angle. Right, because that's the simple equation that we use in 11th and 12th, right? Speed, change in position is equal to time into speed. So likewise, change in angular velocity is equal to time into acceleration, right? That is that. Now angle of A is equal to current angle, which is I plus dt times W of A, which is angular speed, right? Right. So whole part will just this whole for loop basically adds fills the entire data that we have, which this is like the theoretical aspect. It's solved by this is called Euler's method. We are not discussing too much about it. We didn't try. We don't want to interfere too much about it. So now comes the juicy part, which is how to frame the animation for our problem, right? So x x of A is equal to x of A is equal to our a x position which is equal to like we talked by L sine theta, right? So L times L of A times angle of A, right? So basically this will make a 500 array. We are defining these zeros mainly because uh, we don't want to repeatedly increase the dimensions of our array dynamically because it will slow down the problem. Simulations like this usually take time. So moving on. Uh, Likewise, y of a is equal to 1 minute. I forgot that this is sine of angle of a. Okay. So that is that. So that this whole thing will now have the x position x and position y of our simple pendulum, right? Now coming to the animation. So what is animation? Basically, animation is nothing but repeated pictures, right? Pictures play displayed in quick succession. So for that also we will use a for loop. And this so this plot command is basically this plot command will basically draw a line for a problem, right? So this will draw the line from origin to the x coordinates, basically drawing the simple pendulum. Now we will put a hold on. This will mean that we will be plotting over on the same figure without deleting it. So some few adjustments we will make. First, we will make the axis as equal. We will turn on the grid. Now we can confine the plot in a particular window, right? So for that we can define it as minus, right? So this what this axis command does is like basically it will fix a L by A grid on a plot diagram. Okay. Cool. Next, I will add the bracket. I forgot to add the bracket because this is a function, right? 1 minute. Minus L of A, comma L of A minus L of A, comma L of A, comma L of A. With this, we will get a plot. We will also plot this. Now we will turn the hold off and we will add a small time delay using the pause function. Now, now let's just run this program to see what happens. What is the error? Let me see. Invalid expression, line 37. Line 22. Okay, small mistake. Now it should run. Small errors, small syntax errors. So initial angle, let's say pi by 2, and angular speed is 0. Okay, what happened? Okay, another error. So these are like small spelling mistake sort of errors. Okay, 1 minute. I'm just fixing all the errors that we have. Exceeding array position by 1. Why? Okay, let me just refer the code that I wrote originally so that it becomes clear what's the mistake. So this code I have attached in the document. Okay, so this is the whole angle ka thing and all those stuff. Uh, and this is the whole animation ka plot. This is the whole axis equal cut stuff and all those things. And yeah, okay, don't worry about these stuff. These are not that important for now. Let me just run. Yeah, as you can see, we get the simple pendulum ka simulation kit is visible. So this is like the animation that we get. The other thing that I wrote was like the graph of angle speed and everything. So as you can see, this is the animation, right? If the screen is visible, yeah. So this is the whole animation ka thing. Likewise, I would advise all ki like if you want to code in MATLAB, just ask in the community and like if I will just show you in a quick step what to do. Like let's say MATworks. One. So basically MATLAB, all every details are here in this uh, in this help center only. Like if you want to know what is plot function, it's there in the help center. Like it's a plot. And the MATLAB has a like for you can see na the we have all the details for plots. So like all the things that you need to learn are there in the MATLAB website only. You just have to search for all of this. And I think that's my part on over. Annapurna, will you take over?
Do you guys have any doubts to ask? We are free to solve your doubts right now. So we have 6 MATLAB groups right now in WhatsApp. So the sixth group is empty. You guys can join that group. We'll be very free to help you in solving your MATLAB doubts. Uh, and I'll just send it in the chat box. Yeah, I have sent in the YouTube live stream. You guys can join that group. You can ask your MATLAB doubts. We'll be there to help you out if you have any doubts in the future. We'll be conducting more events like this in future to help you guys understand math really well, mainly your syllabus that VIT offers you. So stay tuned to Vitma's YouTube channel and Instagram to more info. Thank you guys for attending the session.
And that's all for today. Thank you for joining. This is VIT Mathematical Association Student Chapter signing off.